Hello everyone, Akshat this side. Good evening, good morning. We have Abhinav, we have Altrash, we have Deepak, Priya, Vishaka, Yugan. Okay, so guys, I will be making you panelists one by one.
Good evening, Akshat.
Guys, will it be fine if I today for this session if I switch off my camera? Yeah, yeah. Thank you guys. Oh, you must be aware about I like some pollution problem in Delhi NCR. So I'm very much reactive towards that. So in November, especially in Delhi NCR is something notorious for being highly pollutive. So AQI is somewhere topping the charts. 300, especially in the region where I am. So it's very common here. A lot of people facing the same issue. So even if I just stop the session, okay, then I will be compensating for what I have left in some days. Okay, so Altrash, I'm promoting panelist again. Same goes with for Princey. Okay, we have few people coming in, so we will wait for another 2 minutes. Ashish, I'm promoting a panelist. So Yugan, you are already in the panelists. Can you please check? Okay, we can get started now. So last time, so before starting, Yugan, please confirm in the panelist we have everyone except Al Atarsh. I can see few new people like uh, Princey, Priya, and Yugan. So three of you are joining the session first time.
Akshat? Hello?
Yeah,
Akshat, are you able to see my name?
yeah.
I'm not okay. I'm not able to see in the panelist.
Okay. I- Can you see my screen?
Yeah, I'm able to see the screen.
So you
Yes.
can see that in the participants, you are into that panelist.
Okay. I'm not able to see my name. I don't know why. Okay, it's okay.
Okay.
Never
So
mind.
you're here for the first time in the session.
No.
Okay. So I didn't saw your name earlier. Same goes for with Priya. Okay. And similar with Yugan. So Yugan, you are also joining this class first time, or you were referring the recordings? Alal Trish, I'm promoting you to panelist again. Okay, fine. No worries, Altrish. Yep. So last time we were doing the confusion matrix. Okay. So what was the confusion matrix? Okay. Confusion matrix was a 2 by 2 grid in case we are predicting a dependent variable which have the values between 1 and 0, yes, no. Okay. Or binary. It means uh, the values of the dependent variable are of two types only, or it's having two values only. Okay, any. So there, when there are two values in a dependent variable to predict, we will predict either of them. Okay, so in that case, we use binary logistic regression. Okay, we can use. Okay, so in order to measure the performance, okay, I introduced you with the concept of confusion metrics. So if you remember this diagram last time we did, okay, let me just reiterate the same thing. I will draw, and I want you people to please respond if you are getting this concept of confusion metrics, because this is quite important. Okay, we don't have right now CV sir. Okay, but we have Viramani, and we have Vishaka from the previous session, Deepak also, and Ashish also, and Altrish. Okay, so confusion metrics for a dependent variable where two values are there, it means a binary. It's a binary value for y. I think it's okay. So means y, which is your dependent variable. Okay, it has how many values? Two values, 1 and 0. Okay, when you're making a model, okay, few things can happen. Okay, either it will able to predict correctly. Let's say you wanted to predict only the ones. Okay, so you're supposing in your case, in our case of the data, one was the male. Okay, in the restaurant, in your retail market, like the data you had previously, with the help of annual income, age, and spending score, you was having male and female. You converted them into a model trainable format where you convert all the English text into numbers like 1 and 0. And with the help of model, you predicted, okay, with the help of model and with the help of independent variables like age, income, and score, you predicted that what it will be. Okay, and then you compared with the actuals. Okay, so the prediction is in the G column. Okay, so scenarios could be like the actual and predicted. Sorry guys for that irritating sound that happens when in cold. So actuals could be like 1 and 0. It means one stands for male, 0 stands for female. Thank you for understanding, guys. Okay, now it can be possible that the model that you made, so model is like your uh, model, I will say that model M1, which will give you the predictions. Okay, which will give you predictions. Now, We know that. Okay. And we have some actual values. So it could be possible that for the males, it predicted the males. Okay. So whatever the number will be, we will note it down. Okay. We will count it. Remember one thing, not summing up them. We will count it. So in our model, looking at the data, we made a objective that with the help of age, annual income and spending score, that is our independent variable, we will predict the gender itself. Okay. So for any model has to choose one value in the dependent variable, whether it will predict that one and other will be automatically derived. Okay. If it is able to predict the male, then obviously because there are two values, so we will be able to know that how many it will predict the female. So for our model, the event which is going to predict, which it is going to predict is a male. Okay. So for us, it becomes that positive. So this becomes positive and this become negative. It's up to you. You can make female as positive also. Okay. So in that case, it will be different, but the interpretation will change a little bit. So for any model, whether it's a any machine learning model, for classification, there has to be a event. So in this case, predicting a male is a event. Okay. And that event is known as the positive. So for example, the actual data was having this as male, this row as male, and model also predicted in the G column as male. Okay. So all those cases where the actuals and the predicted was male, we will count that. And that will become your true positive. So whenever there is a true, it means actual and prediction are same. Okay. And in this case, it will be true negative. Why? Sorry. Because in our case, event is male, which is positive, and obviously the female will become negative. So predicting correctly the females becomes your negative automatically. But it is true. Whatever the actual was and whatever the predicted was exactly the same. So you counted all those cases and you are writing and in this particular box, or I will say that 1, 2, 3, 4. So in the fourth, and that is your true negative. Okay. So you will count all those cases. Okay. So it could be also possible that actually they were males in the data. You can see that there were males like this case, but the model predicted as 0. It means it predicted wrong. So for easiness, it's called the prediction. Okay. So you will count all such cases and those cases will become will be coming in this particular box. What we will call it, because it's a false prediction. So first of all, it will be false. But what? You predicted the positive as false. So it will become your false positive. And here, because it's a mismatch, it will be false negative. Okay. So that is the confusion matrix. Now, how the accuracy was calculated in the previous case. If you know that we build a logistic regression model of the data and we predicted the score of the training and the testing. How that particular score was generated? It was the same score which was generated by this method. Now, what happens in that score? True positives plus true negatives divided by all. So it was like TP plus FP plus FN plus T. So this ratio is called as accuracy. Okay. So this accuracy, if it is 90%, then what we can say that model is able to predict both of the classes, which is like the true positives and true negatives up to 90%. Okay. Is there any doubt till now for this explanation of confusion matrix? Thank you, Deepak sir. What about Veeramani? Sir,
Sir, could you please repeat in short? I have still confusion in false negative, true negatives.
sure. Let me just redraw it. Okay. Let's just consider. So before that, are you comfortable with the concept of the data independent variable and dependent variable?
Yes.
Fine. Okay. Let's make this gender variable. Let's first of all remove all the colors. Okay. In our case, this is your dependent variable. Let's just highlight. This was annual income and this is your dependent variable. So dependent variable, I will color it. Let's say I will color it by green. This is your independent variable. So age, income, and spending score becomes your dependent. So I will have this colored in orange, light orange. Okay. Now, as you know that with the help of these independent variable, I'm going to predict the males or females in my data. Okay. So I will make a model. But in order to make a model, I will have to pass on the target variable, which is my gender, also the independent variables, and I will pass into logistic regression and it will fit and it will make a, as you know, equation. And this equation will now predict the values. How it will work? So if I give you, if as an input to the model, the age, annual, and spending score, it will predict me whether it will be a male or female. Till now, correct? Abhinav?
Yes, correct.
That's great. Now, in order to prepare a model, I will have to do some conversion. Like first of all, model cannot understand this target variable male and female. So you'll have to convert it into 1 and 0. As there are male and female two values, so it will be 1 and 0. So you can see that I have coded male as 1 and female as 0. You can do the reverse also. It's up to you. Okay, so you can see that this is the case. Now, instead of taking this variable, I will be taking Okay, instead of this, I will be taking this variable, the converted variable into the model. Okay, so I will make this as like X train, sorry, Y train, because Y is the universal notation for target variable. Okay, so I will make this as Y, and this all will be my X, which is the universal notation for independent variable. Till now, it should be cleared. Okay,
Yes.
now your model will be a function of X, which will predict some value, which we will call as Y hat. Okay, Y hat. Okay, so let's suppose your model has predicted that it will be a female, and I will color this prediction as let's say a different color, better color. Yeah, this one. And for this particular record, it has predicted correct. If it is was female, then it predicted the male. When this was again female, it predicted as female. When this was female, it predicted as male. Correct. It was female, correctly predicted. Let's suppose it's predicted wrong. Okay. Now you will be able to see that this is the prediction Y hat. Okay. Now, in order to know how the model has predicted, how many correctly predicted and how many incorrectly predicted, the confusion matrix comes into the play. Now, what will happen that whenever your model was created, you initially provided to the model that this will be the function of X, but you should try to predict any of the value which will become your event. So in the initial model itself, it takes that one value for the dependent variable as event. Okay, and that it calls as positive. As it is a binary case, so automatically the zero value, which is non-event, will become negative. Okay, sorry guys. Okay, so model will predict always the event. Okay, and automatically you can derive what is your non-event or the negative. So for any prediction which is stands for female, it will be your negative case, and any case which is like for the male, which will be your positive case. Okay, so you can do the reverse also, it's up to you. Now let's suppose count all those cases where it predicted the males as males. Okay, first case, males as males, where it was, it is not, so I will say that it's not the case. It predicted the male as male, yes. It predicted males as males, no, so it will be NA, 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 NA. But here it predicted males as male, yes. How many yeses? You can do a count if. Okay, I think I'm putting the wrong formula, but I can count it. It's 2. Okay, so it predicted males as males, and where I will count where it predicted males as females. We will check. Yes, it predicted males as females. So yes, males as no, it predicted. So it is NA, NA, NA. Obviously, for females, we will not check it, but it predicted males as females in the last case. No. So it only predicted males as females as one time. Correct? Now we will check whether this model predicted females as males. Obviously, because the original is male, so we will have this NA. Females as males, we will check. Yes. In this case, it checked. It predicted wrong, obviously. Now, females as NA. In this case, yes, it predicted. In this case, NA. Yes. So how many times it predicted females as males? 3 times. And females as females. Obviously NA. Now in this case, yes, females. Yes. Yes. How many times? Here it is also 3 times. Okay. Now in this all 3 or these 4 columns, let's just also make it a little highlighted. What should I do? Color for it. Or let's make it this. So males as males. So whenever it's males as males, so it means the correct predictions. Okay. It means, and it's also females as females. So all those correct predictions. Okay. Where it predicted correctly. Can I say that? Whether it's a positive or negative, but it predicted correctly. Yeah. What about Vishaka? Okay, Vishaka has done. Yes. Okay, fine. What about Deepak sir? Today I'm asking a lot of questions so that I can sneeze in background. Okay, so all those cases where whether it's a positive or negative, whether it's a male or female. Yeah, yeah, Vishaka, you got it. Yeah. Whether it's a male or female, when the prediction was correct. Okay, so we will consider those cases as like yellows. Okay, and where it predicted wrong, males as females or females as male. Okay, consider it a kind of a blunder case. Okay, so you are making a model to predict a particular lady, okay, particular person as being pregnant or not pregnant. Okay, so you can assume that if a lady is truly a pregnant, if you're predicting that yes, this lady is pregnant, then it's fine. But let's suppose if a lady is not pregnant, you're saying, are you pregnant? So it can be a cultural disaster. It can be a kind of a disaster. So you should know that which mistake is bad, which mistake is really bad for the business. Okay. So if you consider this as your thinking, or you apply the logic in any of the case you are having. So let's suppose whatever the business you guys are in, whatever the jobs you are in, consider a case where this situation is required. So if you are working for a quality analyst, so you must be having that, making a product quality as bad or good. So it totally depends upon you as a business person. You will be knowing that which case is critical. Okay. So any case where the misclassification is there, there will be a case in the misclassification itself which will be much more fatal. Okay. So you must be aware about it. So like in this case, both are fatal. Predicting males as female is also bad, and predicting females as males is also bad. Okay. But it can vary upon the situation. Now for all those misclassifications, I will try to make it in a red. Yeah, that's right. That's bad. It's fine. But we will make this as yes. Yeah. Yep. Yeah, Ashish, you calculated it. That's nice. Yep. So, okay. First of all, how many values were there in your overall data? 9. Okay. So your particular total case is 9. Okay. Yeah. Altrish, that's fine. You can also calculate the cases on the basis of misclassification and accurately predict. So if you sum up this one, you will also get this 9. Okay. Okay. I think I'm in getting in a good spot. So I'm gonna switch on my camera. I just had this citizen. I think it's just kicking in. Okay. Now you will be able to see that these yellows are your correct predictions. Okay. So if I say that my model was predicting for the positive, that was males. So males will become that positive. Okay. But it is true case where both of them, like it is that males as males. Okay. So it will become my true positive. And here it will become my true negative. Negative why? Because in our case, the positive is male. So obviously the negative will be that female. But it is the true, like where it is the correct. Actual was also there and model predicted it correctly. So that's why it's the yellows. Okay. Now in this case, as it's a misclassification, so it is both of them are false. First of all, now how the false are? It predicted males as females. So it will be like false positive. Okay, I am doing right. Let me just refer it also. Actual was 0 and predicted was negative. Yeah, that's fine. So both are like false cases where the misclassifications are there. So that F will be there. That is false cases. Okay. But originally it was male, but it predicted as female. So obviously it predicted the false for the positive. So it's become false positive. And similarly for here, it's also a false case. It's a misclassification case. But originally it was females, but it predicted as male. So it becomes your false negative. Now the accuracy is actually the true positive plus true negative divided by all TP. So I will say that yellow divided by all. So yellow is your true positive plus true negative. So let's just calculate it. 5 and your total cases were 9. So accuracy will be your 5 divided by 9. So somebody already calculated that one. Ashish. Yeah. So that's why your accuracy is 55%. Okay. Now, accuracy is not the only thing that you can be relied upon. Okay. If I just refer my PPT back, let me just open it. Internship batch time series, ML statistics. Just a minute, guys. Oh. So meanwhile it is opening, I wanted to know, especially for the people who are new here, Princey and Priya and Yugan. Is this confusion matrix making sense? I don't know what happened to this. Just a minute. I don't know what's happened. I will be opening it into that drive. I'm sharing my screen. So please answer, guys. Princey, Priya, and Yugan. Any doubt? Please let me know. Okay, we have for Priya. Got it. That's great. Ah, thank you, Princey. Yeah, there is a classification report, Altrish, for that. I will come over that. Yeah, it's a good question. So it could be possible that you are predicting a case where it is like, are you happy, partially happy, uh, like satisfied, partially satisfied, or not satisfied? Yes. So in that case, uh, there is a classification report, which is also a form of confusion matrix, but instead, apart from it making a 2 by 2 metric, it will be like 3 by 3. Okay, where was it? Okay, I opened the wrong one. Now the next part is going to be very important. So it's related to that valuation matrices. Okay, you can see that the same thing here. Out of the slideshow here. You can see that accuracy score for classification. There is called balanced accuracy score. There is F1 score. There is precision score. This is a recall. There is Jacquard. There is ROC, AOC score. And you can see that this is the same case I explained to you. So you can have that actual values on that left side also, or you can interchange it. So it's like a transpose of the matrix. But the overall thing is that when positives are match in case of actual and predicted, it becomes true positive. When negatives and negatives match, it is the true negative. And same with that misclassification. So when the positive cases are being identified as when the negative cases are being identified as positive, it becomes your false positive. And actual when the actual positives are identified as negative, then it becomes false negative. And that brings me to the correction here. Yeah. So in our case, what was positive? Males. So when positives are classified as negative, it means males are classified as females, then it becomes false and negative. And when females or negatives are classified as positives, in other words, females as classified as males, then it becomes false positive. Okay. Okay. Yeah. Now you will be able to see that whenever it's a false positive, we called as a type 1 error. The predicted value is positive, but it is false. And type 2 error, the predicted value is negative, but it is positive. Okay, actual. And when you have a ratio of true positive, like the TP only, divided by true positive and false negative, it becomes a recall, which is a better metric to observe when you are predicting for something like fraud or something. Okay. Now, it is the same metric, and you have multiple matrices to calculate here. For example, the accuracy is like true positive plus true negative divided by all. That was coming out to be 55% in our case. Let's say you wanted to know how precise is your model, not how accurate is your model. How precise is your model? Then it becomes a different altogether case. That precision is known as the recall in machine learning language. Okay. Now, these companies, when they hire, they ask a question, which is a more important metric, accuracy or recall? And they give you a case. For example, insurance companies fraud. So it could be possible that there are out of 1 million, there are only 10,000 frauds, or out of 100, there are 2 frauds only, while 98 are genuine cases. So what is the advantage of making a model if it is correctly identifying 98 genuine cases as 97 genuine cases, and while rest of the 2 cases which are very rare, it is falsely predicting? Okay. Even in that case, if that 2 cases which was for your model as positive, it is predicting them wrong. In any case, its accuracy will be higher because it is predicting the majority as accurately. So in that case, accuracy doesn't help. So I'm going to repeat what I just explained once again because it is too much to observe. Let's say out of 100 insurance claims, two of them are fraud. So while 98 becomes your genuine cases. Let's say uh, I'm drawing here. Let me just draw here. I don't know what happened, but let's draw here. Insurance okay, everybody is aware that insurance company provide claims. Okay, and sometimes people do some hanky panky and fake the claims and try to have money. Okay, so that becomes as fraud, and these companies pay hefty amounts to predict these kinds of claims early in the process. That becomes your fraud prediction model. So obviously it's a yes or no. Either it will be fraud or no fraud. So we will make a ML model, okay, with the help of some variables. So model will be having, let's say, 20 variables, and at the end, it will predict some y hat. Okay, because you have the historical data, so you must be aware that your fraud prevention team already identified in the past that this particular claim was fraud. So obviously you are making this model with the help of the provided data which was having the fraud tagged. Okay, so you will make a model, but in that case your company is not very much efficient in predicting the fraud, and fraud are very less also. So out of 100 there were two frauds. So it means that 98 are. Till now, any doubt? Okay, so let's say your model is prepared. Okay, and model is giving you accuracy of 80%. You will say that, yeah, wow, it's a great model. Okay, it is able to predict. You will understand, you will misinterpret that it is able to perform accurately the predictions at 80%. Okay, let's make this number even more, 98%. But what will happen is that you know that accuracy is actually your TP plus TN divided by your all. In our case, what is our all? 100. What was your positives for your model to predict the fraud? That was your positive. And in your case, model predicted as 1 as the fraud and 0 means genuine case. Okay, so 1 means fraud, 0 means no fraud. Okay, so model was built to predict the fraud, or in machine learning language we will say that, in that lingo we will say that fraud was your event which is positive, and it is a non-event and it is negative. So how this 98% came up, let me just show you. 0 plus 98. It means that true positive was 0 and true negative was 98. And that's why you got 98% as accuracy. Now, what is the meaning of this? It means it is not able to predict the fraud. It was only able to predict the non-frauds correctly, which was actually not the purpose of your model. Your model's purpose was to predict the frauds, not the non-frauds or the genuine cases, because there is no value in there. Even if you are able to predict 5 frauds, then you can save a lot of money. Okay, so accuracy is not a better metric. What if I tell you that there is a better metric called recall, which actually have a formula of true positive divided by true positive plus false negative. Now how this is thing? It is true positive divided by true positive plus false negative. Now come to this false negative. It means that the case which was positive but it was predicted to be negative. Let's see what is that case. False negative. See here. False negative. It means the actual was positive but it predicted to be negative. What if in the case of fraud? Actually it was fraud but the model predicted as genuine. That becomes your false and negative. So if I say that, let me just cut it up and paste it here. So we know that true positive we are aware, but it is the ratio of true positive plus true positive plus false negative. So if I say that, it is exactly the sum of what's happening. It is the sum of this one or the actual positives. Can I say that it is exactly the sum? The denominator is actually the sum of actual positives in your data. It means the actual frauds. Okay, let's say in your data, actual frauds were 2. Obviously, your 2 was there. Plus, how many the model was able to predict? 0 and 0. So that will be that particular ratio. Obviously, it will say that your model is almost poor. Let's say a better case. Okay, let's say a better case where there were 100 cases in totality and there were 4 cases of frauds. Okay, out of 100. And model is able to predict 2. Okay, in that case, the recall value will be like 2 divided by 4 and it was like 50%. Is it a better metric to predict that or to know that whether your model is good or bad? So recall is a better metric in comparison to accuracy, because accuracy considers your non-interested cases or the negative cases also. Even if your genuine interest is into predicting the positives, it will consider all that. Okay, and that's why it deviates a lot. Okay, and those cases where your event is very rare, like 100, and there were four genuine cases, four frauds cases, that called imbalanced data set. Okay, where the positive class or the negative class is having a lot of difference in number. And in machine learning lingo, we call them as majority and minority. So in our fraud case, what is the majority? The genuine cases. And what is the minority? The minority is your fraud cases, where there is a majority and minority of the positive classes. Then it becomes an imbalanced data set or the imbalanced class problem. Okay, and fraud claim prediction is a imbalanced data set problem. Okay, guys. So that was the whole story about that recall. Now, apart from recall, there are few things which is like precision score. There is a recall score, there is a precision score. So, but you should be knowing only these two things: accuracy score and recall, and why recall is better. Okay, you should be aware about it. So all these theoretical aspects that I told you, you should be knowing it from an interview point of view. Now, should I now go to that logistic regression model? Now you will be able to see that I am able to make a confusion matrix. And this confusion matrix is giving me the accuracy score, or the base for that, our recall also. So we should be knowing that this follows the same order like the confusion matrix, and you will be able to know that it is a 2 by 2 grid. So you can fetch out the true positive, false positives, and a true negative and false negative, and you can do the calculation. Okay, but there is a better way to do it, which is from sklearn dot matrices import. You can directly get it. Okay, so like F1 score, and there is recall score directly. So you will have to pass on the predicted and the actuals, and it will create the recall score itself. Recall score, and it will require your prediction and your true values. So let's just pass it. So y train and your y prediction, and you will be able to see that the recall score is 40.9%. So it's like somewhere around 41%. Okay, guys. So any doubt I can. Okay, guys. So any doubt I can take till now? Okay, that's great. That's great. Okay. After that, I will be coming to a case of classification report where the Altrash ask a question where if it is like possible that there are not binary cases, there are 4 to 5 cases. Now you will be able to see that from sklearn matrices, you can have this classification report. Let's just read what it says. Classification report. It also takes the true and your predictions. And what it gives is that what it returns, it gives you precision, it gives you recall, it gives F1 score, and it gives you support. Okay. For the uh, overall data. And you can have like class 1, class 0, class 2, something like that. So it doesn't have like binary cases. It can have multiple cases also. So we will do with another data set, because in our data set we have 2 classes only. Okay, so I will have another data which I will be able to demonstrate how the classification report is generated and how the confusion matrix looks for a multiple value scenario. Okay, so here what you do is that you press your shift and tab. Okay, and once you press the shift tab or simultaneously, you will be able to see this kind of a option. You can have this option, show the show that content in full, so you will be able to see this one. Yeah. I'm really sorry, guys. So, guys, I won't be able to take more because even I have taken a very strong medicine, but still, I'm not feeling comfortable. And there's a kind of irritating sound that even if I'm attending a call, somebody's sneezing, and so I can understand this. So, will it be possible that if I pause here, like we will stop here and we will continue with tomorrow? Yeah. Thank you, Shaka. Yeah. I absolutely apologize for this because, but I know it's kind of a environment there, so a lot of people facing this issue. Okay, guys, so I hope I will be in a better position to deliver this lecture better. Yep. So, guys, meet you tomorrow. Yep. Thank you, Deepak. Thank you, Altrash. Okay, guys, so I'm stopping here. Uh, let's just meet tomorrow. Okay, guys. Bye.